Morning guys, we are doing a combination of sum to another combination by arrays class. So this is a good problem where you can see that there are two arrays. Suppose in example 2 there is one array, in example 1 there is one array. So in the first array you have to break the array in such a way and make combinations out of the elements of the array such that it becomes to a value k. So you can see that n equals to 5 is the number of elements and k equals to 7. So 7 denotes the possible sum of the elements which makes it up to 7. Say for example 1, 3 and 3 is there, so it makes it up to 7. 2 and 5 can make it up to 7. So there are two possible combinations out of the 5 elements which can make it a possible combination. So before doing this, we'll write the main thing, how we are going to solve this. So we are going to solve this using backtracking of recursion. So backtracking and recursion. Okay, so nothing else is there. Let's just check the topic tags. So if you see the topic tags, it is saying recursion and arrays. So I'm just hoping that I'll make a new playlist today on recursion. That would be helpful. So before that, let me make a backtrack. Let me make a resultant array list, right? So I can say list, and in this list I can take the list data type, take list of integer type, say name the list as result equals to new array list. So when the array list is being made over here, what we can do is we can sort the array list. So arrays sort which array? The array given by the user, which is ARR. So you can write it like that, arrays dot sort ARR. So once the array is being sorted, so I can write over here sort the array. I can write over here make a new array list. And also I can mention over here k denotes the value which it becomes sum. ARR denotes the array given by the user. Okay, n denotes the size of the array. So once these things are made, once the array is sorted, what we can do is we can call a backtrack recursive method. Backtrack, we can pass the result, we can pass a new array list. So new array list, and we can pass the array given by the user, the total sum value and the starting position. So I can write over here 0 denotes the starting position. Okay, so once this is done, I can return the result. So I can return result or return the list, because the type of the return type of this function is list. So I'm returning the array list, returning the array list items. Okay, so now the main task is I have made the list return function, but I have to make the backtrack function, right? So I can write like this as private void backtrack. So this is using the recursive function. So over here I will take a list. Okay, so as parameters you can see we have passed result. So obviously how is the result is adding as a parameter? So I can write it like list, then I can write it as integer, okay, result. This is our first parameter. Second parameter is also a new array list. So I will pass a new array list, it's a temporary array list. So I can name it as list. Again I have to give the name as integer. List is of integer type. Say temp is the name of the list, and int ARR will be the array, because you can see ARR is also there. Then again in case of k I can write like this int remain, and in case of the 0 I can write like this as int start. So this is basically denoting the the starting position from which backtracking will start. Remain denotes the remaining sum value. ARR denotes the value which is array given by the user. Temporary list to store the values. Okay. So next what we are going to do is we are going to check. So while checking we can write like this: if remain less than 0, we can give a false return. Okay. Else if whenever we are doing an else if, we can write like this: remain equals to 0. So there is no previous sum value. So we can add result.add. We can add our new array list. We can add the new array list to the temporary list. So temp. Okay, we have added the result. Once the else if part is done, we can construct the else part. So in the else part, what I'm going to do is I'm going to traverse through the array. For int I equals to 0, we will not put 0, we will put start, because we are using the start value. I less than the length of the array, or we can take it as n. Okay, that's the reason we have given n, but since n is not present in the parameters of the backtracking function, we have to use arr.length, or else we have to make n as a global variable outside the scope. So what I can do next is I can check if I is greater than start, or the present index is greater than the starting index, and the ARR of I or the present element is equals to previous element I minus 1. I minus 1 is the previous adjacent element's index. So we are checking the present element is equals to the adjacent element in our first if condition. Okay, so in this if condition we can write continue. So what is this if condition basically denoting? It is telling to skip the duplicate, because duplicate means the present value is equals to the previous value, which is satisfied in this if condition. So if duplicates are found, we are going to skip it by continuing the duplicate. Lastly, what we're going to do is we're going to add in the temporary list. Add We can add the result. We can add first in the temporary list. We can add the current element. So what we can do is we can write over here adding the current element. So next, after adding the current element, we are going to recursively call the function backtrack. So I will select the name backtrack over here, write it over here backtrack, and in the backtrack you can see first I have to pass a list. So temp list will be the first list, then another array list. So what I can pass is first I'm going to pass the result, then I'm going to pass the temp. Once the temp is passed, we can pass the array. Then we can check the remaining elements. So or the sum of the elements minus arr I, and we can continue to go deeper through the traversing by increasing the counter by I plus 1. Yeah. Next we are going to temp dot remove, basically remove the current element from the list. So temp dot size minus 1. What are we doing basically? We are removing the current element backtrack. Okay, let's check the else. For loop is closed over here. Okay, if statements are closed, while backtrack is also closed, and class solution is closed. Let's compile. So you can see backtrack it cannot be basically the problem lies over here that whenever I'm backtracking it, the parameter I have passed over here as a int arr, but I have to write it as int arr third bracket because this is an array, and over here we are also passing an array. So that was a silly mistake. Let's just compile it. Yeah, so it's working. So after this I will do a code analysis this particular problem. So what we can see next is whenever we are doing the documentations of this particular code, we can see is whenever we are doing this matching, class solution has been there, so which defines a class solution, and the list is basically taking the parameters and it's returning the list of integers. So this method will be responsible for finding all the unique combinations in the array where the sum of the combination is equals to k. So if the sum of the combination is equals to k, I've already mentioned over here, then it is saying we have to sort the array. A backtrack function is there to backtracking check all the possible combinations, and then we are going to return the result. So next, you can see we have used temp list or add, which adds the current element of the array, and update parameter explore combinations while the remaining sum and starting from the index. So these are the like basic explanation of the code. Here is the code. So I hope you understood the problem. So you can write over here. I've inserted the comments over here in order to make you understand it more easily. Thank you. See you on the next video.